Good morning, everyone, and thank you for attending this presentation on the Leonardo Energy Academy RETScreen courses. My name is Frederic Pouillot, and I'm the director of the Clean Energy Institute of GPEX, and the company that we're the company that dealt with Leonardo Energy to create those courses. In this presentation, we're going to cover the following topics. First, we'll start by discussing the potential for renewable energy. This will give you an indication of why basically you should bother with renewable energy and due diligence tools such as RETScreen. We'll talk about the critical importance of due diligence in the process of initiating renewable energy projects. Then we'll discuss the place that RETScreen has as a due diligence tool. I will explain why the Leonardo Academy courses are different from the other Leonardo Academy courses, specifically the power quality courses, and explain why we have used PowerPoint PDF presentations versus just HTML text. I will then give you an interactive tour of the Leonardo Energy courses. We'll look at some sample courses that we've created, specifically the energy efficiency and solar photovoltaic courses. And then we'll talk about the benefits of passing the exams for the Leonardo Academy courses in order to maintain professional certification and accessing other certification courses in feasibility analysis. First, let's talk about the potential for renewable energy. Well, renewable energy is currently the fastest growing sector of energy, but not only that, but it's actually, of all the industries, we're looking at construction industry and all the major industries, automotive industry and various type of industries, one of the most promising and fastest growing sectors for the decade to come. It has been growing at a very fast rate, typically 20 to 50% a year based on the type of renewable energy technology, and we can expect that to continue. Let's look at a breakdown of the technologies covered in the first 5 courses offered through Leonardo Energy. Wind was actually the technology that we covered first. Wind represents the largest segment of the renewable energy sector if we exclude large hydro, and is 8 to 10 times bigger actually than the second largest sector in terms of capital cost invested, which is solar PV. It has been growing at typically, based on the countries, here between 10 and 20%, and we can expect that growth to continue, especially in some areas such as, for example, the offshore sector. We can anticipate the next 5 to 10 years that there's going to be a boom in that area. The UK is currently a world leader in the development of those type of projects, but we're seeing a growing number of projects in other countries, in Germany and France, and even in North America. There's some projects now going in the eastern part of the US, and there's some big developments also in Texas and some other areas of the Americas. We're going to also see a lot of development in emerging form of wind, urban wind, which often can be used also as a hybrid solution, for example, in for not only lighting applications, but a growing number of applications where even if the grid is not very far, it's actually it can be cost effective to use vertical axis wind turbines. And developing countries offer a really interesting potential. South Africa is a good example of that. There's big developments going on there, and same thing in Central and South America, as well as some parts of India. Solar photovoltaic is the second technology that we, second course that we developed, and solar PV is the sexiest, the most exciting of all the solar technologies, and definitely presents the biggest potential for growth. While the wind resource is not present everywhere on the Earth, certainly there's solar radiation covers a vast, presents potential in vast areas from almost the pole to pole, and of course there's a big potential now around the equator in developing countries where solar is becoming is either grid competitive or probably will be there very shortly within a few years. We're even forecasting that, well, not just we, but the analysts, experts are forecasting that even solar should be grid competitive with nuclear energy, even in France, for example, within 2 or 3 years. So it represents a very large potential for growth. While it's starting from much smaller base, we're going to see much more developments there. And I want to mention that there may be a little bit of confusion there because we're hearing about bankruptcies and consolidation, but what's happening is that the decrease in price for solar photovoltaic is creating some challenges for the competitors, but what's going to happen is that with consolidation, we're actually going to be able to see stronger, less manufacturers, but stronger manufacturers, and they will be able to achieve greater economies of scales, and this will help to continue the decrease of the price of production of technology. We're also making a lot of progress in balance of system, in making more efficient support structures, inverters, and also the whole process of developing projects. The soft costs, we're seeing a lot of reduction in that area. So this really is increasing the competitiveness of solar PV over grids, not only in the developing world, but worldwide. And this actually now we're seeing that in without subsidies, PV is already competitive in a number of states in the US and in many parts of Europe where electricity is above 20 cents per kilowatt hour, US cents. So a great potential there, especially also with new advancements in technologies in thin film, in concentrating solar technologies, and new with the Desert Tech initiative, for example, new advancements with the Saudi Arabia and some actually all countries betting on solar. There's the plans for over 40 gigawatt of solar just in Saudi Arabia, and India also has 40 gigawatt, and some countries are looking at 50 gigawatt. I mean, this is a very, very exciting potential. Small hydro, there's still a lot of potential for small hydro projects in the developing world. Most of the good sites, the cheap sites, have been developed, but in the developing world, this is a different story. There's still a lot of potential, and there's especially a lot of potential for a run-of-river type of project, what we call kinetic hydro, just using the movement of the water, as well as energy from the tides, from the waves. This is about to explode. There's some right now convergence of of technologies, and I think some very innovative type of technologies coming out. Cogeneration represents a vast potential. We've also created a course on that. There's a lot of potential to use agricultural waste or municipal waste to produce electricity, and also a lot of industries are typically, let's say, need a lot of heat, and from there could be using electricity, or vice versa, produce electricity, producing also a vast amount of unused heat that opens some markets that have been untapped. And the methane and the gas that escapes from waste is very toxic. Actually, it creates 20 times more pollution than burning CO2. So this is very important from an environmental perspective. And this creates opportunities for basically any city that has a waste treatment plant, or many agricultural facilities, and especially the one that produces a large amount of waste. Energy efficiency is our fifth course, and of course, what we call the negawatts, the negative watts, is by far the cheapest form of electricity production. We can produce that for typically half the cost of the cheapest renewable energy technology, and there is increasing pressure from governments, municipal governments and federal, state governments who are imposing regulations to either reduce the pollution or to be more efficient. And so this is, another form of incentive. Is basically either the capital cost or the procurement or financial incentives, and then there's the compliance incentive, which basically force people to do something and to invest into more efficient energy production. So we've developed a course there that covers 13 points, 13 different aspects. Now, why is due diligence so important to a renewable energy project? Well, this is typically the first step for any project of any significance. Of course, if it's a very small individual residential project, the homeowner, the small company may do their own verification, due diligence. But if you're looking at any project of a magnitude, we're talking about hundreds of thousands or millions of dollars or euros, then due diligence will be required by the site owners. So for example, if you're doing a solar PV project on a college, then the college will likely, especially if they're putting some of their own money, will need to be able to verify that the project is viable, that it can provide some return. The project developers, of course, require that, and the due diligence may either be done internally by the project developers, or if they don't have expertise in the technology, they subcontract that, or they deal with another company. For example, if a utility company has developed mostly other forms of energy, hydro and gas plants, they may not know about wind or solar, then they would need some consultants or external companies to help them. And of course, the company that finances projects, such as people that provide debt, the banks, or people that provide the equity, whether we're talking about the venture capital or other type of private investors, they will need to have some due diligence, some feasibility. And finally, regulators also need that. So the governments, and they need to be able to verify the impact of a project on the people and the physical environment, the animals, the wildlife, and so forth. What are the components of due diligence? And it's important to understand that so that we can see, where tools such as RETScreen can help. So the most obvious one is probably the technical aspect. You need to be able to verify how much energy is needed, what the renewable energy resource would be. For example, what is the solar resource or the wind resource, or at what velocity does the water flow. You will also need to be able to look at the logistics, for example, the transport, and bringing the wind turbine to a remote area through mountains and windy roads is not a small logistics concern. And then for the site, of course, you need to be able to understand that site beyond the energy needs. For example, if you're doing a solar project, you need to understand the potential for shading. If you're doing a wind project, also potential for wind turbulence. And if you're doing a hydro project, you may also need to look at, beside the tectonics, the potential variation in climate and so forth. The technological aspect of feasibility is related to the products that can be used to produce the energy. So for example, you need to understand the what type of turbines you can use for wind energy, or what type of solar panels can be used for solar thermal or solar photovoltaic, the type of power conversion equipment, all the inverters and transformers and so forth. And support structures also, what type of technologies can be used for anchoring, for the foundations and so forth. Due diligence also includes some other aspects, and those are not typically covered in depth by tools such as RETScreen, but they're important organizational aspects, making sure that you have organizations that have the capabilities to deliver the training, the understanding, the experience in terms of regulations. Also make sure that your project is using, for example, equipment that is going to be approved by the regulators in terms of electrical norms and standards. Of course, environmental impact. Doing a project on for example, a wind project on a bird migratory path may present some challenges. Economic aspects, of course, is after technical, it's typically the most common things that's looked at in due diligence. You need to have a firm understanding of the initial cost. Of course, those initial costs themselves depend on the design, which is a result of technical analysis, and also from there you can derive the operating cost and the end of project, such as decommissioning or credits that you can have at the end of a project if basically you have a technology that can potentially outlive the initial 20 years or whatever. In the case of hydro projects, obviously a dam will has a potential to live more than 50 years. And then, of course, clean energy also means clean energy due diligence means evaluating the opportunity versus the risks. So the anybody that puts money into a project wants to have a really good understanding of the risks and the sensitivity to critical factors such as sensitivity to price of displaced energy or to solar radiation or wind speed and so forth. So RETScreen is a tool that while it cannot cover all the aspects of due diligence, it will certainly be very useful for many aspects of the technical analysis and economic analysis, as well as some parts of the risk and sensitivity analysis. So RETScreen as a due diligence tool. Well, in order to be cost effective, we need to have tools that allow us to basically reduce the cost, and RETScreen certainly can do that. Some cases can reduce the cost to about 1/10. Of course, it depends on the level of analysis. If you're doing a preliminary analysis, RETScreen is great for that. When you're going to levels of more detailed analysis, then that may require, for example, for a wind turbine to install a meteorological station, or if you're doing a solar project, to install some equipment to measure the solar radiation, a parameter. And of course, for that you need more than RETScreen, but definitely RETScreen is a very important tool for the initial aspect, the preliminary aspect. It will allow you to be more effective and efficient. So that's very important, to basically have tools that allow you to do the right thing and to do it as efficiently as possible. Of course, nothing will replace the experience, but certainly that will be a lot better than just using more manual processes with calculators or even some homemade worksheets. So the process of reducing costs can be achieved thanks to tools, templates, and experience. And RETScreen is one of the most widely used tools worldwide for preliminary analysis. Now there are a number of tools that can be used. In the US, they like the System Advisor tool, and NREL also has some other tools, but those tools tend to be actually quite technical, and sometimes they we don't need that level of detail until we actually get into the design of a project. Also, System Advisor, for example, deals with US currency and imperial measures, and so what's nice about RETScreen is that we can work in either system, and it uses also a weather database, and that is global. It covers the whole planet, and it covers also a multitude of technologies that are typically not covered by all the those other tools, including energy efficiency. And RETScreen also has a tool for measurement of performance, RETScreen Plus tool. So RETScreen covers all those 5 technologies that are covered in those initial 5 Leonardo Energy courses, but it also covers passive solar and solar thermal, solar water heating, ground source heat pumps, biomass heating, and you can actually also use it for some other application, because the tool is fairly flexible, so that you can actually if you know the capacity of a project, it can be pretty technology agnostic. The Leonardo Energy RETScreen courses are designed to give participants a very good understanding in terms of the theory and also practice for how to use RETScreen, because there's a number of case studies, a minimum of 4 to 5 case studies per course. The energy efficiency course has over a dozen, covering a wide array of situations. And I just want to mention that in regards to the RETScreen tool, that there are really two. The new RETScreen suite has two parts. What we're looking at here for the due diligence on doing the preliminary analysis is mostly the RETScreen 4, even though the RETScreen Plus tool, which is designed for energy monitoring, can be used, let's say, by looking at the performance of past projects in order to be able to help with future projects. So in that sense, it could be useful, but mostly here we decided on the courses to focus on RETScreen 4 for the cost analysis of and technical analysis of upcoming project of not project that have been commissioned, but project that are considered. So why are the Leonardo Academy courses different from other courses? Well, first of all, it's important to understand that we really wanted to design courses that are very hands-on. They're very case study driven, and it's not just theoretical case studies, but we wanted people to get their hands dirty by actually trying the software and giving you step-by-step instructions on how to do things. And that cannot be done very well just by using the type of approach that has been used by Leonardo Academy for other courses with mostly HTML pages and PowerPoint type of presentations. Here what we needed to do is to provide enough in-depth background text, and that is in order to be able to deliver enough quantity of material, we had to do that through PDFs, which we could have really reduced the amount that we covered and by making some pretty HTML pages, graphics, but that would have been very time consuming and would have had to reduce somewhere. So we decided to go that way, and also PDFs allow people to let's say print the document and just follow the steps. You minimize the amount of paper that you use, or if you want to also follow the steps on two screens, one screen with the PDF file and one screen with the where you practice on your RETScreen, that is more effective than just using a multitude of small HTML screens that people have to spend a lot of time navigating through. So if people find that's a little disorientating at the beginning, hopefully you will appreciate in the end. Now we've been developing courses for close to 10 years now, and we've tried different approaches, and we found that this is really what works best for our type of courses, for this type of no, it doesn't work that way for all the courses, but for this is what we found is better. So let me just now go through the interactive presentation. Just want to give you a little bit of a quick tour of the software. So once you go into the Leonardo Energy website, then you'll see at the end there that you have a number of courses that we have created for energy efficiency. So the first one that people need to take before they can take any of the other ones, well, they could take the other ones, but they would be lost and they would be totally inefficient, is the introduction course. Okay, so that's the pre-requirement, and so this one is not so much hands-on. It's a little bit like if you want to again, if I use my let me just hide that here to maximize my window. Okay, there. If you want to there learn to drive, then you've got the initially you got to learn the theory, read through a book, and after that, you get the hands-on. So this kind of like a little bit the theory, the driving test theory. So we explain what the model is in more detail, and in this course we go through anything that is not specific to a particular model. So in other words, understanding how the software is organized, and then for example, here greenhouse gas emission, that doesn't really depend on the technology. The procedure to analyze greenhouse gas emission is the same. It's technology agnostic. Same thing for financial and risk analysis. The financial indicators, understanding the inflation and what is the discount rate and rate of return and those type of things, they are not specific to a technology. The approach to do a sensitivity analysis in RETScreen will work exactly the same whether we're looking at a wind project or a PV project. The only kind of more hands-on part at the very end there is we just get you to work through the installation of the software and looking at how to work with the files. So let's look at, for example, here the solar photovoltaic course. Okay, so the way we organize that is we have 6 sections. The first section is the background on the technology, where basically we provide the general information just so that you can understand what you need to understand to be able to conduct a preliminary analysis in RETScreen. It doesn't cover all the aspects of a feasibility analysis. Again, for example, in RETScreen you're not going to do an environmental impact assessment or a detailed engineering study, but you need to understand what the technologies are, and also because of the economic aspect, you need to understand the type of cost. So we provide some documents such as the International Renewable Energy Agency study that was performed and released in 2012, and other documents on the levelized cost of energy. Then after that, we provide case studies. So we covered some typical examples of different applications. So we've got on-grid solar energy, residential scale. Of course, very similar type of approach could be used for commercial scale. And we've got then off-grid, okay, solar energy. We use a vacation cottage here, but that could apply to an off-grid industry. Then we looked at utility scale photovoltaic, a 10 megawatt project. In this case here, it's based in Mexico. And we looked at off-grid solar water pumping. We have a case study in India. And then we show examples of isolated grid, such as, for example, grids on islands. And I just want to show you, for example, what the guided assignment looks like. So I got a PDF document. Okay, I just resize that here so that it's visible. So we basically provide all the information for how to get started with the project, and we give you along the way all the information, all the background information for that type of project. So just for example, here looking at the solar radiation, okay, we explain basically how we can evaluate the solar radiation using either the ground station or the NASA database and so forth. So this is the approach that we've used there. We provide you also the background information. For example, if you're doing a PV project and we talk about batteries because you need storage in off-grid applications, and then we will give you some files such as the starting file and a finish file for each of the projects, and provide that in different forms. The basically the red file here may contain the different subsets of files. I'm not going to open that here. I'll just let's open this one. Okay. It's takes a few seconds to load RETScreen and all the macros. Position that here. There you go. Okay, and so in the end also we provide the finish file that shows the information so that you can check your work against the basically the completed file. Of course, you have to make sure that your macros are enabled. If not, some of the features won't work. No, the important features won't work, especially in risk analysis. Okay, so basically this is the way we organize those files. Maybe I'll just give you, it's going to take too long here, so I'll just close that. Okay, RETScreen. There you go. Okay. RETScreen sometimes can get a little slow. It's got lots of macros. Just to give you a quick tour of the last course on energy efficiency. Just showing all the topics here. So as you can see here, we covered a number of topics. After the general introduction to energy efficiency, we cover building envelope, heating and combustion systems, hot water, cooling and air conditioning, electrical equipment, lighting, motors, pumps, fans, steam systems, heat recovery, refrigeration, air conditioning, and compressed air. And every time again also we have basically we provide case studies after the overview. So I hope that this will help you. Now just to finish the presentation here, I want to talk about the benefits of taking those courses and passing the exams. Okay, first, one of the benefits that the people will be well equipped to actually take the CI courses, which allow people to get continuing education credits and maintain their status as a professional engineer or architect through the Association of Energy Engineers, where we have an agreement with them. And if you go to the cleanenergyeducation.net website, actually it explains how that works. And in order to make it easier for you, actually, once you've taken those Leonardo Energy courses and you're really well equipped to challenge the Clean Energy Institute's certificate of proficiency process, that will really give you a good solid start. The certificate of proficiency process requires actually that people take some facilitated courses where we have a subject matter expert that will guide people through actual real world studies, feasibility studies, to do that process. And basically it's for each technology it's a 4-part process where people need to take the introduction course. Normally it's $200, but people that have passed the Leonardo Energy courses introduction will get $100 off. And then also people will get $100 off the facilitated theory course, part of the Clean Energy Institute certification proficiency course. So for example, if somebody is interested in solar PV certification, normally the introduction course is $200, they would pay only $100, and then after that the facilitated theory course is $700. People will be able to get that for $600. Then so that's the theory course. They would still need to complete 2 real world studies, once they pass that, they obtain 70% average, then they would actually be able to get our certification of proficiency in solar PV technology for the analysis of PV project. So I think that my time is up here. This session will be posted on the Leonardo Energy website, and if you have questions, then we'll arrange to have a question and answer session. Thank you very much.